We've already looked at integration approximation in two ways. One was, they're both through Riemann sums, and these had to do with rectangles. Right, there were specifically right-hand rectangles and left-hand rectangles. And all right and left-hand rectangles ultimately meant is the location where you were finding the height of your rectangles. So if we had a curve that's doing something like this, and we wanted to make rectangles using the left-hand rectangles, the height of our rectangles would always be at the left-hand side of the curve. And so we would be doing things like this. And you might have some overestimates or some underestimates depending on what the curve was doing. And to exaggerate a little more, a right-hand rectangle simply meant, I'll use just y equals x squared in this case, that the right-hand side of the rectangle is where and how it was, the height was being calculated. And so the principle was just using areas of rectangles with the height being found on the right-hand side. And sometimes these intervals were unique, and sometimes they were the same. But the idea was still areas of rectangles with the height being found at either the right or the left-hand side. Now, another type of approximation is called the midpoint approximation technique. And the idea is the same. We're still using rectangles, and I'll still draw a picture using y equals x squared. And in this case, instead of using the left-hand side or the right-hand side, the height of the rectangle will always be in the middle of the rectangle. So our picture is something like this. And you can see the midpoint is good because you might have an overestimate on one side and an underestimate on the other side, and those areas and lack of areas would cancel one another out. So that's the principle behind the midpoint approximation. The final kind of approximation that is important for our purposes is called the trapezoidal approximation. And all this is taking areas of trapezoids, conveniently enough. So trapezoids have bases that are connected, right? A trapezoid by definition is a quadrilateral with one pair of parallel sides. And so each of these trapezoids would have an area. And you can see that even with my drawing, it's pretty accurate because it can get tighter to the curve. Right, and to do a trapezoidal approximation, you just need to recall that the area of a trapezoid is the average of the bases times the height. And each of you may know that a slightly different way, or 1/2 the height times the sum of the bases. Right, but be familiar with the area of a trapezoid and you can do a trapezoid approximation.